of tangent line to the parabola y equals x squared at point 4, 16. So in order to understand this, we must first understand that this is point P. And point P would be, let's see, 1, 2, 3, 4. Let's say this is 16. Would be right around here. Okay? 4, 16. So this is point P. And the tangent line would have a point somewhere, let's say, here. So in the scope of things, this slope would be different than the slope of this entire parabola. So we need to find Q. We can do this by finding the slope first. So let's first plot out or analyze what we have here. Or sorry, not 3, 9. 4, 16. So this is x, this is y. And then our Q is x and x squared. All right. So in order to find the slope, slope is equal to delta y over delta x, which is also equivalent to y2 minus y1 over x2 minus x1. So let's go ahead and plug those in. So we know that y2 is x squared. We know that y1 is 16. x2 is x, and x1 is 4. We can solve this further by factoring to simplify it. X squared minus 16 also equals x plus 4 and x minus 4. Bring over the denominator x minus 4. So we know that these cross out and we're left with the slope equals x plus 4. But what's x? In this case, x is 8. Or sorry, x is 4, which makes the slope 8. So now we can go ahead and plug it. This signifies that when the limit is 4, because as we see here, the x is 4, when the limit is 4, the slope of the tangent line is going to equal 8. Now we use our numbers to plug it in to this equation to find the slope, or the equation of the tangent line. Plus m x minus x1. Okay, so we know that y1 is 16 plus our slope, which is 8, times x minus 4. Let's use the distributive property here. 8x minus 8, 16, 24, 8, 64, 32, plus 16. And we're left with y equals 8x minus 16. That is the equation of the tangent line to the parabola y equals x squared at 4, 16. All right, next question. Find values of the 6 trigonometric functions corresponding to pi over 6. So first we must understand the right triangle. This side is 1. And this side is the square root of 3. We know that based off pre-calc and stuff we've learned previously. But we must find the hypotenuse. And now how do we find the hypotenuse? Well, let's simply use the Pythagorean theorem. C squared equals a squared plus b squared. C squared equals, let's plug it in. A squared is 1. B squared is, parentheses, square root of 3 squared. We know that the square root and square cancel out, so we're left with c squared equals 1 plus 3. C squared equals 4. What squared equals 4? 2. C equals 2. Okay, now that we know that, we can find our 6 trigonomic functions. Something I like to use is what I learned in high school. It's called SOHCAHTOA. Now this applies for sine, cosine, and tangent. But let's go ahead and do it. So, sine is equivalent to opposite, which is this, over hypotenuse. So, that's one already right there. Okay, let's keep moving. Cosine, pi over 6 is equivalent to adjacent over hypotenuse. So, square root of 3 over 2. Let's see sine. It's equal to, or sorry, not sine, tangent. Is equal to opposite over adjacent, which is equal to 1 over the square root of 3. Now that we have these, we have to find the secant, cosecant, and cotangent. We know that these equations are the opposite of what they are here. So, let's keep it going here. Alright, so the opposite of this, opposite of 1/2 is 2. The opposite of this is 2 over negative, or square root of 3. And the opposite of this is square root of 3. So, these are your answers. Okay, let's go to solve this problem now. Find the limit. The limit is 0, tangent x over x. So, we must solve this algebraically, because if we solve it by just plugging in an x that's close to 0, no matter what, we're always going to get 1. So let's solve it algebraically. So the limit when x turns to 0 of tangent x over x is also equivalent to the limit x over 0 of sine x over x multiplied by 1 over cosine x. And if we solve this equation, we actually learn that this is equivalent to 1, because 1 times 1 equals 1. Now, why does this work this way? So when we plot sine of x on a graph, the line should look something like this. And if we were to plot a regular y equals x slope, we would get something like this. So the problem is that sine of x and the actual x itself are pretty much similar. So sine of x is almost equivalent to x if x is like a little bit smaller than 1. And so that's the solution. Okay, let's go to solve this problem now. Find the value of a, making the functions continuous. So here's a. So we have to find what makes these functions continuous. So first we need to understand our limits here. Our limit here says that x approaches 1. So let's plot this out actually. It says that x approaches 1 from the left side. So, but it never reaches 1. So let's say 1 is here. It would be a little bit something like this. Let's say this is 1. It would keep on rising and rising and rising, but never touch 1. Now let's say that x is greater than or equivalent to 1. This heads towards the positive infinity. This means that this line also can touch 1, but we'll go, or I'm sorry, the first line here will go to the negative infinity because it goes all the way here to the left. And this one here will go all the way to the positive infinity. So let's go to solve this equation here. Since our limit is 1, if we plug in a number that's really close to 1, like 0.99999, it's pretty much equivalent to plugging in 1. So let's just plug in 1 at this point. Okay. So, in order for this function to be continuous, we need to make both of these equations equivalent to each other. How do we do this? So, what we can go ahead and do is we can make this equation ax minus 1 equivalent to 5. This would make the equations equivalent. So, let's solve. And we know that x is 1 minus 1 equals 5. Plus 1 plus 1. A times 1 equals 6. So, a equals 6. So, our solution to this problem would be 6. Since a equals 6, the function would be continuous and there would be no gaps between this function, patching this gap here. Okay, now we must find the vertical asymptotes of the following: f of x equals x squared over x squared minus 4. So let's draw a graph. The vertical asymptotes are lines that go straight up and down like this. Now, in order for this to happen, the y must equal 0. So what can we plug in here to make y equal to 0? Obviously, we can plug in 0 in the x, but that would just be this line here. So we need to find something else that we can plug in to make the y equal to 0. Now, what can this be? So the way I look at it is, off the bat, if we find something squared that's minus 4 and equals 0, we know that we found the right answer. So what squared minus 4, or what squared minus 4 equals 0? Yeah. So let's go ahead and do it. We know that 2 squared minus 4 equals 0. So if we plug in 2 to this equation, let's solve. It's 4 over 4 minus 4, which is 4 over 0. So boom, we already found one vertical asymptote here, which is 2. Now we have to find another one. Well, we know that negative 2 squared is also 2. So if we do negative 2 squared, this is also going to equal 0. So that's our other vertical asymptote. What does the vertical asymptote mean? Well, it means that the function is going to be somewhere in between these lines. So if we were to plug in a number, let's say the number was 1. If we were to plug in 1 to this equation, we get 1 over negative 3. And if we were to plug in negative 1, it would also be 1 over negative 3. So that means that this parabola is always going to be going towards negative infinity within these lines. So that is the solution. Okay, now let's go to solve this equation, or this problem here, similar to the one that we did in problem 1. Find the slope of the tangent line to the graph f of x equals x squared at point 39. So our goal here, let's say this is our x squared. Let's say this is 39. We have to find the slope of a certain q. Let's say q is here. Slope of this line here. Now, how do we do this? Well, we have to put delta y over delta x. We know that our p is 3, 9, and our q is x, x squared. So now let's go to solve. This also equals y2 minus y1 over x2 minus x1. If we were to solve this, we would plug in our problem first. So let's start with x squared minus 9 over x minus 3. How do we solve this? We factor. By factoring x squared minus 9, we get x plus 3 and x minus 3 over x minus 3. We know that these cancel out and we're left with m equals x plus 3. What is our x? 3. So, in this case, our slope would equal to 6. So this slope here would be 6.